All right, so let's talk about. I want to make sure I'm recording. I want to make sure. Oh, we are. Good. We're going to talk about. Let's get one. We're going to talk about the respiratory system. So this would coincide with chapter 10 with Airway Management. For us to really have a good understanding of how we manage the airway, we first have to understand the purposes and the function of the airway itself. And one question I want to answer is, right off the bat, why do we need to breathe? Oops. There we go. Why do we need to breathe? Well, it's very simple. So we can pick up oxygen and we can get rid of carbon dioxide. So we want to add the oxygen and get rid of, eliminate the carbon dioxide. But why do we need oxygen? Well, we need oxygen to perform what we call aerobic metabolism. And this is essentially how the cells of our body produce energy. How they power themselves. And so, if we talk, we think of cells as these really teeny tiny, almost insignificant things that we've read about, but we don't see them because they're microscopic. We got how many billions of them as well. But the cells are what we're made up of. If we talk real quick about the basic structure of life, the basic fundamental building block of our bodies are cells, right? So you have the cell, and then on top of that you have tissues. So cells make up tissues. Tissues then will go and make up organs. Organs will go and make up organ systems. And then those organ systems make up an organism. So an organism, like us, we're humans. So that's kind of how the structure. So we need to feed the cells in order to feed all of us, right? And so the way the cells do that is through aerobic metabolism. Let me get my yellow back. There it is. So aerobic metabolism. And all this aerobic metabolism is, it is the breakdown of glucose. Of glucose molecules. And this term is what we call glycolysis. Glycolysis. So glyco means glucose or sugar. The suffix lysis means to break down. So sugar breakdown. There are other terms for this. You may have heard terms like the Krebs cycle, named after the guy who discovered it. And then there's a really fancy term called oxidative phosphorylation. Right? Screw that. Just to know that we know about it. It's pretty much the exact same for aerobic glycolysis. That's for aerobic glycolysis. There is anaerobic glycolysis, which we'll talk about in a minute. But this is how we make up, how our cells get energy out of the food that we take in. And it needs oxygen in order for it to function. So what happens when we do glycolysis, when we break down, we take that, I'm going to go back to yellow here. We take that one glucose molecule, and we'll just say that so I don't have to draw a molecule, and it gets broken down into 2-pyruvate, a chemical called a molecule called pyruvate. And so there's 2 of them, right? And if oxygen is present, or enough oxygen, if an adequate amount of oxygen, we're going to make that blue. Where's my blue at? There we go. So adequate oxygen and oxygen's always paired together. You never have a single oxygen. Oxygen always likes to bind together. If there's adequate oxygen, this pyruvate and that oxygen, they'll go into the mitochondria. Mitochondria of the cell. And this is the, oh, my blood just burnt out. That's all right. I'll survive. So the mitochondria is what we call the power plant of the cell. And with that oxygen in the mitochondria, the pyruvate go through tons of chemical processes with a whole bunch of different enzymes to release the energy stored in these pyruvate molecules. And it's super efficient. And this process provides a ton of energy for the body. In fact, it's so efficient that one glucose molecule will yield 36 what we call ATP molecules. And ATP is the energy that powers it, right? So a 1:36 ratio. Now, I think technically, if I remember my biology, it actually produces 3 ATP, or 39 ATP, but it loses 3 ATP to power this whole process, which is still a pretty good return. If you were to think about buying a stock in a company for $1 for $1, right, and you got a return of $36 on that, I'd say that's a pretty good swap, right? Or more technically, $3 and you get 39 back. That's pretty good. So that's why we need it. This process works with oxygen, and the cells are so dependent on this process that if you don't have either enough sugar or enough glucose, or more dangerously, if you don't have enough oxygen present, you cannot do the aerobic metabolism. You actually go into what we call, let me get a different color here, we'll go purple, what we call the opposite of that, which is anaerobic. And that's a process of glycolysis. So we're still breaking down glycolysis. So we're still breaking down the sugar molecule, the one glucose molecule, but it's without oxygen, without O2. This occurs in the cytoplasm of the cell. And it doesn't yield a whole lot. One glucose molecule is only going to give you about 2 ATP, so 2 energy. This is not enough energy to power the cell. So what happens if you cannot power the cell to do cell stuff? The cell is going to die. Now, we've heard of anaerobic metabolism, like if we're in ketosis or something like that. You know, I know the whole the low blood sugar, or I'm sorry, the not eating sugar, all that stuff. That's kind of a different process. This is when we don't have oxygen. There's not inadequate. It helps if I spell this right. See, look at that. Change it to an A from a Q in a. Oh, that's supposed to be an E. Quit. Oxygen. There's not enough oxygen present. Your body's going to go into this. It can only handle this for a few minutes, maybe not even that, before these cells start to die. And like we saw up here, you might think, wow, well, only one cell's going to die, no big deal. Yeah, but look at the cells make up the tissues. Tissues make up organs. Organs make up. And so if enough cells start to die, you start getting tissue death. And then if enough tissues start to die, you start getting organ failure. If we think about and look at this difference. Look at the difference between aerobic metabolism. You get aerobic metabolism. It's going to produce you 36 ATP versus anaerobic producing 2 ATP. And this is per 1 glucose. Now, if we're normally supposed to be in aerobic and we're not supposed to be in anaerobic, look at what aerobic is normally producing us. This shows us that we need this much energy to power cells. And this is not going to cut it. This 2 ATP is not going to cut it, so those cells are going to start to die. They're going to start to go. And if enough cells start to die, then tissues start to die. If enough tissues start to die, well, I already went through that. And then, so we can really see how important oxygen is and why we breathe. Now look at another question to ask, or to really relate to how important oxygen and oxygenation is to our patients. Look at our breath rate. How many times we breathe in a minute? Depending on what you read, approximately 12 to 20 times per minute. 12 to 20 times per minute. We are breathing. That is once every, now if we do it in reverse, that's once every one breath every 3 to 5 seconds. That is a heck of a lot. So let's look at, let's do the math. So here's 60, and we're breathing, 12 times a minute. There's 12, well, yeah, we don't need to do the math on that. We breathe a lot. We'll save the math. We breathe a heck of a lot. So that can show you how important that is, how many breaths we take, throughout the day. Okay, so that was bugging me, so I had to do the math, and you always show your math, always show it. So we breathe once every, now as adults, we're right more probably around this 12 breaths a minute time, and that's at rest. Keep that in mind, that's at rest. So if we breathe once every 5 seconds, that's about 12 times a minute, and there are 60 minutes in an hour, so 60 times 12, 720 breaths per hour. And there are 24 hours in a day. 720 times 12 is around 4,280 breaths a day. This shows you, not 90,000. See, that's why we get that out of there. That's a lot of breaths. That's a lot of breaths. And then look at another thing. When I was, researching for doing this, I looked up energy expenditure. And your body, now we're doing this, your body only spends about 3 to 5% of its daily energy on the process of breathing. Which is pretty remarkable. I mean, you'd think that we're breathing 4,280 things, if you do anything 4,280 times a day, you should be exhausted from it. But we're so well designed and so efficient that we hardly even notice when we're breathing, when we're at rest. This tells you that when people develop distressed breathing, it becomes exceedingly exhausting and very, very dangerous for them. So that's kind of a big overview of how important it is for us to breathe. I know this doesn't really touch on airway management, but what it does is it helps us understand how incredibly important it is that we adequately assess and effectively manage a patient's airway and breathing. It's vitally important so that we don't let patients slip into the anaerobic metabolism and those cells start to die within minutes. We hear that phrase that, well, how long can your brain go without oxygen before those cells start to die? And it's like, well, okay, 4 to 6 minutes. Well, I'd actually argue that it's far less than that we truly need to take that breath. Now, this brings up an important point, though. Our respiratory drive, and I'll mention this in a future video, our respiratory drive, our drive to breathe, is actually CO2 driven, right? Our body senses elevated CO2 levels, and so we have to expel them. And that's from the aerobic metabolism, right? CO2 is a byproduct. So once the CO2 gets too high in your blood, your body tells you that you need to take a breath to expel some of that. And then, while we're at it, we're going to pick up oxygen. The hypoxic drive, and hypo means low. Oxic, or ox means oxygen, right? So the low oxygen drive is kind of our backup drive. Certain people with certain conditions, we'll talk more about in a different video, they get accustomed to elevated CO2 levels, and to where their body really can't sense that they're too high, and that's going to be in COPD and maybe some people with CHF type of issues, to where they take a breath because they're getting low, they're getting hypoxic, which is already really bad for you, right? So, well, that's it for this video. I'm going to stop right here, and I'm going to make, yeah, that's good enough. This is a good enough place to stop. I hope this helps. Let me know if you have any questions on this. Let me know if it's a good video and you like it, and we'll see you at the next one.